Okay, we've got a derivative question here, and by the looks of it, quite a laborious derivative question. We're asked to use the limiting chord process or the definition of a derivative to differentiate this cubic function here. Now, just to refresh your memory, the limiting chord or the definition of a derivative is we've got f prime x can be described as the limit. Now I'm using h. Some people like to use delta x, but I'm going to use h. As h approaches 0 of the function of x plus h minus the function at x minus the function at x, not the derivative at x, come on mate, divided by h. So that's our definition of a derivative. Now, this is going to be quite a laborious question, and the way I'm going to try and minimize the probability of me making a mistake is I'm going to break this up. So first of all, I'm going to find what the function of x plus h looks like. Then I'll subtract the function of x. I'll then divide it by h, and then I'll take the limit. So it's a way of trying to minimize the probability of you making a mistake, because a laborious question like this isn't really testing your ability to use this function here. Rather, it's testing your ability, like your algebra ability, and your ability to make sure you can follow through the whole process without making simple algebraic mistakes. So let's have a go. The function of x plus h. Now, when we figure this out, all we're doing is we're replacing the x's in this function with x plus h. So this is going to be equal to 3x plus h all cubed minus 4x plus h all squared plus 7 x plus h minus 5. Now, this doesn't really help us at all. What we need to do is we need to expand these brackets. So we can do this in 2 steps. First of all, we're going to do the expansion of x plus h all cubed. Now, if you're aware of how these power functions are expanded, you'll be aware that so you can quite easily just write x cubed plus 3x squared h plus 3x h squared plus h cubed. Now that's just the use of Pascal's triangle to work out what that expansion is. Similarly, we're going to use the same sort of method. I might put it in another video of how that would work, but I'll have to expand this one, so it's going to be x squared plus 2xh plus h squared. Now I've got this plus. Now we can just multiply this bracket out now, because it's going to be 7x plus 7h minus 5. Cool, we're almost there. So now we have to just expand using the 3 and the negative 4. So this is going to be equal to 3x cubed plus 9x squared h plus 9x h squared plus 3h cubed. Now, those of you who are still following, this process would, your teacher or your professor would have to be an interesting character to put this in an exam, because the process is quite long-winded, but it could happen. So this is going to be minus 4x squared minus 8x h minus 4h squared plus 7x plus 7h minus 5. Great. Now what we're going to do is we have to minus f of x from f of x plus h. So I'll put it in a different color. So if we look at this is our f of x plus h. Now I'm going to minus away f of x. So that's going to be minus 3x cubed now it's minus 4x squared, so if we minus a minus we get a plus, plus 7x, so we're going to minus away the 7x, and we have a minus 5 here, so we plus 5. Okay, now what you're going to hopefully notice is we have some like terms in the front and in the back. So if we notice we have 3x cubed here and negative 3x cubed here, so they'll cancel out. We have negative 4x squared here and positive 4x squared here, so they cancel out. We have plus 7x here and minus 7x here, so they're going to cancel out. We have minus 5 here and plus 5 here, so they're going to cancel out. So then, after that, we are left with, so the top line of our definition of a derivative is now going to look like this. 9x squared h plus 9x h squared plus 3h cubed minus 8x h minus 4h squared plus 7h. And now we'll put this all over the bottom, which is just all divided by h. Now, if we were going to take the limit of this function as it stands at the moment, what would happen is if h tended to 0, the denominator of this fraction here would tend to 0, making the whole fraction tend to infinity or tend to an undefined number. So what we're going to do is we're going to use the fact that the numerator has a common factor of h to cancel out a h term with the denominator. So to do that, we have to first factorize the numerator by h. So that's going to be h bracket 9x squared plus 9xh plus 3h squared minus 8x minus 4h plus 7. And that's all divided by h. Okay, so once we've got to here, we can cancel out these two h's, and we can introduce the limit. So we can say that f prime of x is equal to the limit as h approaches 0 of 9x x squared plus 9xh minus 8x minus 4h plus 7. Great. Now, when we look at this, it's quite simple to see, or quite easy to see, that if h goes to 0, this term here will go to 0, and this term here will also go to 0. So we can disregard these two terms, which will leave us with, so if we take the limit, we then can write our, after taking the limit, we can write our derivative as 9x squared minus 8x plus 7. So that's using the limiting chord process to determine the derivative of a cubic function. And you can see throughout it's quite algebraically laborious. Like, you have to do a lot of algebra, a lot of cancelling. But if you are able to do ones of this scale, scaling them back to do quadratics or even linear functions using the limiting chord process in a test or exam will be quite easy. Well, I hope that helped, and see you next time.